This is lesson 7.5. We are going to be finding the surface area of pyramids. Now remember, the surface area will be the area of each face of the three-dimensional shape. And we should remember that there are two types of pyramids. We have square-based pyramids and triangular-based pyramids. So let's start by looking at this try it question. It says, find the surface area of the square pyramid. Draw a net to find the areas of the base and each face of the pyramid. So if we look at this image, we see that it's a square pyramid, which matches what I underlined in the question, because the base of this three-dimensional shape has four sides, which is the square. So I am going to sketch our net. The easiest way to sketch the net of a square-based pyramid would be to make our square. So you should be sketching it the best you can in your notebook. A square should have four equal sides, so you should try and sketch that as close as you can. And then you're going to have a triangle coming up from each of those edges. So I just like to make a dot like in the middle there. That way I have almost centered triangles. So here I have my net of my square-based pyramid. And now I'm going to represent I'm going to write the measurements that they gave us on the picture on our net. So if I'm looking at the square base of our pyramid, what is going to be the base and the height of that square? The base and the height of the square is going to be 6. And a square has 4 equal sides. So the base of each of these triangles, or the edge where the triangular face meets the square face, is going to be 6. So already looking at this, I'm going to be able to find the area of that square in the middle. Now let's look at the triangles. In order to find the area of the triangles, I need a base and I need a height. So we're going to have a dotted line up, which will be our height. And what is the height of the triangle based on the picture? The height of the triangle based on the picture is going to be 8 centimeters. So on my picture here, I can represent the 8, which is my height. So I'm labeling my net with those measurements that we have in the picture. So now we are going to be doing some math. We have to find the area of each of these faces. So let's start with the area of the square. Our area formula for a square is base times height. So now I'm going to plug in the numbers that match my base and my height of my square, which is 6 times 6. Oops, not 66. 6 times 6. So what is the area of the square? It will be 36 centimeters squared. So I'm going to take that 36 centimeters squared, write it inside my square, and circle it. So the 36 represents the area of the square. Now we have to find the area of the triangle. We'll think back to the area formula of a triangle. What is the area formula of a triangle? Area of a triangle is base times height divided by 2. So let's look at our triangle. What is the base and what is the height? The base is 6. The height is 8. We're dividing it by 2. So 6 times 8 divided by 2 would be, I'm running out of room. If you're doing this in your notebook, you wouldn't be running out of room. Will be 24 centimeters squared. So each of these triangles would have an area of 24. Write it in the triangle, circle it. And how many triangles do I have? I have 4 triangles. So we took our three-dimensional shape and we drew it as a net. Then we labeled the net with the measurements that match the picture. Now to find the surface area, which will be the area of all of those faces, we found the area of each face. And then our last step is going to be to add up all of these faces. So you could do 24 plus 24 plus 24 plus 24 plus 36. Or since we have 4 24s there, you can do 24 times 4, which should be 96, plus the area of that square, 36. So our surface area is 132 centimeters squared. Now let's look at example 2, which is finding the surface area of a triangular pyramid. The question says, Tamara made a small gift box that has the shape of a triangular pyramid. So we know that this pyramid has a triangular shaped base. The faces of the box are identical equilateral triangles. That's important there. Identical equilateral triangles. What do you think that sentence will tell us about the 4 faces of this triangle? The word equilateral is a big hint. So, identical equilateral triangles is telling us that all 4 faces are going to be the same. They'll have the same area. So the question is, how many square centimeters of cardboard did Tamara use for the box? Now, we have our triangular based pyramid here. I see that we have some bases that are 5 centimeters. And what's the height here? The height would be the 4.3. So even though that 5 is listed twice there, I guess they're just showing us that they're equilateral triangles. They have the same base. So it's going to be a little tough to sketch it. So actually, I want you, in your notebook, let's try and sketch this equilateral triangle. The square-based pyramid. So I would start by making, there's a few. We would start by making the one triangle. And then that triangle comes down like this. So we have 2 triangles. And then we're going to add our last triangles on the sides. So there we have our net for our triangular pyramid. Now we know, and look at the hint here, that the faces of the triangular pyramid are 4 identical equilateral triangles. That means that they will all have the same base and the same height. So what is the base of one of these triangles? The base of one of the triangles is 5. And what is going to be the height? The height is 4.3. So now we are going to use that information and plug it into our area of a triangle formula. Area of a triangle is base times height divided by 2. I plug in what I know. My base is 5 times my height, which is 4.33, divided by 2. Put it in your calculator. What is the area of one triangle? The area of one triangle is 10.825 centimeters squared. So that tells us that one of these triangles is 10.825. Circle it. 10.825. Circle it. I have it 4 times. I have it in here. I have it in here. So we have 4 of those 10.825s. So 10.825, you could either add it up 4 times or we can just multiply it times 4. The area of this triangular pyramid, you should get 43.3 centimeters squared. Now let's look at number 5 here. It says the faces of this triangular pyramid are equilateral triangles. That's the big hint that this is a triangular based pyramid. All 4 bases are going to be identical. It says draw a net of the pyramid and use it to find the surface area. So we are finding the surface area, the area of all the surfaces of this pyramid. So start by drawing your net. You have a big triangle. You have your top triangle. And then divide your bottom triangle into 3. Now, this doesn't really look like 4 equilateral triangles or 4 identical triangles, but that's okay. It's just a sketch. So let's find what we know. We have to find the base, find the height. What's going to be the base of one of these triangles? The base will be 12. So I'm labeling one 12. If that's 12, this is 12, this is 12. All of the bases of my triangles. Now my heights. Well, my height would be coming down from the point, forming a 90-degree angle, right? Remember, you look for that 90-degree angle. So all of these dotted lines, I'm just sketching it. You really don't have to do that every time. I just want to show you where the heights would be. The height is this 10.4 feet. So then we would have, and there's not really much room here. The height there, 10.4. What's really important for you to just see is that we have 4 faces. So now we're going to find the area of one triangle. We use our area of our triangle formula, base times height divided by 2. Let's plug in what we know. We know that a base is 12 and the height is 10.4. So area equals 12 times 10.4 divided by 2. So what is the area of one triangle? (62.4 feet squared. So that means that we have one triangle that's 62.4. We have 2 triangles that's 62.4. We have 3 triangles that are 62.4. We have all 4 triangles that are 62.4 feet squared. So I can add that all up, or I can do 62.4 times 4, and my answer is 249.6 feet squared.